Hello and welcome, everyone. My name is Monica. I am a developer advocate here at Starburst, and I am so excited to welcome you to our Open Data Stack panel. We have three awesome data leaders in the house today. I am so excited to get their unique perspectives. We've got Michel Tricot, Ryan Blue, and Justin Borgman. And I am going to ask them some super fun questions about the data ecosystem, where they see the future of data going, and essentially get their perspective on where we are as a data community today. I am extremely excited to get started. And in order to kick it off, what I want each of them to do is give a little introduction to yourself, share the company you started, and a little bit about how you became your path towards becoming a founder. So Ryan, if you want to kick us off, go ahead and get started.
Oh yeah, no problem. So I'm Ryan Blue, CEO and co-founder of Tabular. I also was one of the original creators of Apache Iceberg while my co-founders and I were at Netflix. So our founder journey was very much a surprise. We started talking to all these nice investors that were just curious about Iceberg, and then realized at some point that it made a lot of sense to build a business that helped people use it, that took care of sort of all the platform problems that we were solving at Netflix, but do that as a managed SaaS service. So I think investors knew it way before I
did. That's awesome. That's always good to have that kind of confidence in what you're building. Justin, do you want to kick us off? Tell us a little bit about Starburst and your journey.
Sure. Yeah, Starburst is the people behind the Trino project, formerly known as Presto. My co-founders are the creators of Trino. Trino, of course, being a incredibly fast, highly scalable SQL query engine. Works very well with Iceberg, by the way, to create sort of an open data warehouse. I'm sure we'll get into that at some point today. And my path to becoming a founder, this is actually my second startup. So my first one was back in 2010, and that was a early SQL engine for Hadoop, kind of the first data lake, if you will, and maybe early thoughts around what a lakehouse might look like in the first place. That company was acquired by Teradata, and I just was determined to go do it again. So in 2017, left Teradata to form Starburst, and the rest is history.
And I'm very thankful you did. There we are. Michel, would you mind telling us a little bit about your journey?
Yeah, of course. So I'm Michel Tricot, and I am the co-founder and the CEO of Airbyte. And Airbyte is what we call a data movement platform. We help companies move data from point A to point B. So how do you break down silos, and how do you make data available in systems where it will bring value? So it can be a warehouse, it can be an Iceberg, wherever you want. My path to becoming a founder is actually something I started that's my first time starting a company, to be clear. But I had a lot of side projects on the side, and I think it's every time people ask me hey, how do I become a founder? I say, yeah, you need to make it a real thing. It cannot just be a side project. Otherwise, you're going to burn yourself out. And I've done that a few times over the year, of burning myself out, trying to have my regular job and at the same time trying to start something. And I think at some point you just burn out and the idea dies. So that's how I came to start Airbyte in early 2020, when COVID started. That was also a good being thrown in the pool.
Yeah, I think that's great advice. By the way, I give similar advice. It requires a total commitment, right? You just can't do this part-time.
Absolutely. So I think an unusual question, something around turning, into a business. As a founder, you're always seeing data differently. And so Ryan, you kind of touched on this already, people were telling you how you were seeing that niche data problem, but I like to ask the question, what was kind of that catalyst? How are you actually viewing data differently? How did you know there was a space for you in the data ecosystem? So Ryan, go ahead and kick us off.
So I've actually evolved on this quite a bit through the years, how I see data and our place in it. Because originally we were just building what we thought made the most sense. Essentially, we had a data lake that had very few guarantees and almost no reliability. And we said, hey, can we make this operate like a data warehouse with schema evolution and transactions and all those crazy things that are so core to productivity, but we thought we didn't need in the Hadoop era. And so we just were attacking a problem as a technical problem. But what we ended up doing was, sharing data successfully across products like Spark, Trino, and, later on data warehouse products. And so, I've started seeing this through the lens of centralization and what a game changer it is to centralize data in one place and let your engines come to that data rather than always pushing applications to the engines that happen to have it. So I think centralization is like the biggest part of our story and how we see data changing.
Absolutely. Justin, do you want to touch on that a little bit? Kind of what was the niche? How did you see that, you and Martine, Dana, David could view data differently, and Camille and Matt and everyone else?
Sure. Yeah. So, at the time when Presto was created and which became Trino, what Facebook was trying to solve for was really to build their own data warehouse. In fact, they used the term data warehouse, but build it in a very different way. It had to run at their scale, which is hundreds of petabytes of data. It had to be incredibly fast at that scale. So, from the get-go, queries had to run at internet scale, essentially. But also, it had to be built on open formats. And, back then, I don't think Iceberg was quite yet invented, maybe being conceptualized in Ryan's head. But, the predecessors, Parquet files, ORC files, certainly did exist really from the Hadoop era. And so, the idea was, can you build a open data lakehouse? We didn't call it a lakehouse back then, but an open data warehouse, if you will, that could have scaled to handle Facebook scale, because certainly they didn't want to buy Teradata or Oracle. That would have, cost hundreds of millions of dollars at their scale, maybe even billions. And so they needed a different solution. The other thing that was very unique from the beginning was the ability to federate and actually query other data sources as well. And of course, Facebook has one of the largest MySQL deployments too. So being able to connect to another type of database system and join a couple tables was also inherent to its core design principles. For me, being acquired into Teradata from that first startup, what I was thinking about was, interestingly, how all of Teradata's customers at that point, or certainly close to all, had data lakes, had other databases. Not one had actually consolidated everything into a traditional enterprise data warehouse, despite Teradata being the leader at that at the time. And to me, there was an opportunity to actually create data warehousing like functionality, but outside of the data warehouse.
Awesome. We'll get to centralization later for sure. Michelle, what about you? How did you see, Airbyte coming into play and your niche?
Yeah. So actually, I also come from the Hadoop world, and like AGFS, all the good things, all the MapReduce. We're using cascading at the time, but we're also working at internet scale. We're working like in AdTech, MarTech ecosystem. So like hundreds of petabytes of data on our systems. The thing that was interesting is, yes, you had good technology at the time. Now they're way better, to be clear, for storing data efficiently and for doing something with data, not at the latency that Facebook was doing. We had long running MapReduce job, but still we had a way to extract insight from this data. The thing that we had to rebuild internally, and we had to do thousands of those, was how do we bring data from, at the time it was LiveRamp where I was, we had to build thousands of connectors to bring data from our customers into our Hadoop cluster. That was the first part of it. And then we had to build thousands of those to actually, once you've processed that data, how do you send it to Google? How do you send it to Facebook, et cetera, et cetera? And here I'm just talking about the main ones, but there are like thousands of players in the ecosystem. And I was responsible for the team that was doing both the ingest and the ingress and the egress. And coming after LiveRamp, I was at a different startup, and I ended up doing the same thing. It was for map, for map data, how do you ingest like incident data, probe data, etc. And when at some point I was just, okay, I'm just rebuilding everything I've done in the past. And what I've done in the first year of starting Airbyte was going with this problem space, which is every single person, every single company is going to become a data company in the future. Because before it used to be only the big players that would care about data. Now it's even a small Shopify shop cares about the data. And we were talking with a lot of companies, and they were using existing product, but they were always rebuilding a similar product internally. And that to me was really the deciding factor to start Airbyte, which is, you can buy, of course, but you can also find a way to just bring a system directly into your infrastructure to get that data in. And we're giving you the tools to actually build all these data connectors so that you can connect every piece of data across your system. And that was really the niche problem that we saw. I don't think it's niche. I don't think like Iceberg or Starburst are niche problem. I think they are just solving a real data infrastructure problem, which is how do you make something out of all the data that you own and that you have. So.
And you didn't want to have to go build it a third place. You're like, let's open source it. Let's get it out.
I'm doing it a third time or fourth time, actually. But this time I'm trying to do it for other people as well.
There you go. That's a great perspective. So as we jump in here and we start talking about the open data stack, the ecosystem as we are, let's kind of take an assessment of where we are today as a data community. So Ryan, as of March 7th, 2024, how would you describe the current state of data? What do you think we're doing well, and where do you think we need to improve?
I think interest is really high, right? Everyone, every company is becoming a data company. And so like the realization that this is important is really critical. And I think that's great. We need to play catch up in some areas. Security is definitely one. Like, you've got, I think, two lineages or two worlds. The data warehouse world that Justin was talking about, where you ended up with silos because it was a vertically integrated system. And then you've got the Hadoop world that just didn't have any of the SQL behaviors, like no security, no access controls, like let's leave things wide open. That's something that absolutely needs to change. And it's scary that governments are coming to that realization before companies are. I think there are good ways to attack that problem, but we need to fix that, and we need to sort of get infrastructure in order. So I would say my top two asks are get security in order, and number two, like modularity. We need to focus on modularity and how we use a suite of products and build architecture from them, rather than being in this world where we have one monolithic warehouse. I just don't think we're there anymore, or we may not have ever been there.
I love that. We really may not have. Michel, what are you seeing? Are there any sort of repeated challenges that are coming up in the data space today that you see either with architecture or mindset?
Yeah, I think we're in let's call it the V3 of how the world is approaching data. And I would put the Hadoop and the early version of Spark as the V2. It's a V3, meaning that it's a land of opportunity for a lot of companies, for a lot of vendors. And I think whenever you have like a change in paradigm, a change in how people think about data, there is so much fragmentation. Like you have like maybe 100 ways of graphing your like graphing your data. Like, and the problem when you have so much choice is like the same way when you're at a Subway store and you're just doing your sandwich. You have to think about every single item, whether it's like lettuce, tomato, or whatever, and you forget what you're trying to achieve, which is at the end of the day, I just want my sandwich. And I think we're a little bit in that space where people have so much choice that they only focus on, hey, what is the next shiny object that I can bring into my stack, rather than figuring out actually what does it actually means to build that V3 of data. And like having that choice, like I think kills a little bit of the first principle thinking, which is the data infrastructure is not different from any other infrastructure. It's just you need to be able to move things around. You need to be able to store that thing, and you need to be able to process it. And that's the only thing that matters. And if you want to be in the new world of this V3 of data, this is what you need. You need movement, you need storage, and you need processing. And that's all. The rest, as Ryan was saying, is just, it's a matter of modularity. Like, yes, you can decide how you want to graph your data, but don't start by this one. Start by your first principles. Start with storage, start with processing, and start with movement. And I think that would be the thing that's going to get clearer and clearer as the V3 mature. But yes, fragmentation creates the wrong, it loses people sometimes.
Use that modularity to almost keep it simpler, which is really helpful.
Yeah.
Justin, what do you think is the biggest misconception about data today? What do you think are the pitfalls that people are facing?
Yeah, I was trying to think what is the biggest misconception, because there are a few, but
your favorite.
I'll pick one that's I think changed a lot in the 15 years that I've been doing this anyways, which is that and I think still exists today, but is changing. There's been this longstanding perception, and for good historical reason, that lakes can't provide the performance and functionality of a data warehouse, that there's this just inherent gap. And if you need performance and you need the functionality of active data warehousing and updates and deletes and so forth, you've got to go use a cloud data warehouse. And the reason I think that perception exists is because back in 2010, when I was doing my first startup, that was largely true back then, actually. I mean, that's what we were trying to solve back then with my first startup. And building database systems is hard and takes a long time. And trying to get to a point where you can deliver the same kind of performance as a highly optimized database system takes many, many years. The good news is, like, we're there today. Like the performance differential between a cloud data warehouse and a lake house, if you will, is negligible, to the point that it really doesn't even matter. And especially when you take into account the total cost of ownership, the flexibility, the openness that a lake model provides. And so I think that's a gap or a misunderstanding, if you will, that has been narrowing, but still exists in places where people think that I need a data warehouse, I need a classical cloud data warehouse, and the truth is you just don't anymore. And there are so many thousands of companies now that have proved that to not be the case.
Well said. Absolutely. So pretty quickly following the cloud revolution that has happened, there was an idea of this new fancy modern data stack. And it really was gaining popularity. And it's funny because a lot of people have different definitions for it. So you'll go to one blog, which will have one definition, and another blog will have another definition. So it's really interesting how this has came to be. There's no really industry standard. But what I'm going to do is kind of read a definition, and I want to just get a thumbs up or a thumbs down if you generally agree with the definition of the modern data stack. And I've pulled this definition from our friends from Mode and ThoughtSpot, kind of collaborated what they have here. And so let me read that and just let me know what you think. So the modern data stack is a flexible data infrastructure composed of a collection of tools and cloud data technologies used to collect, process, store, and analyze data. And it's usually composed of a bunch of tools like an ingestion tool, a transformation tool, a cloud data warehouse, or a data lake for storage, and a business intelligence and data visualization platform. So thumbs up, thumbs down if you kind of relatively agree with that definition for the modern data stack. Okay, Ryan, let's dive into it. What do you think?
Well, so mine, I'm not trying to be prescriptive. I'm trying to be descriptive and say like what
Perfect.
I hear people talking about when they talk about the modern data stack is not the or data lake part of it. It is
Perfect. So
the modern
let's
data stack to
edit it.
me is anchored by a cloud data warehouse. You know, Redshift, Snowflake, BigQuery, something like that, and all these tools that can take advantage of exactly that architecture, right? Hey, we have, you know, really high performance SQL, and we can all agree on the interfaces between tools and the data warehouse, and then like that just works really well, and it has the modularity component that we want, but it's anchored on that data warehouse.
Absolutely. I think this speaks to the turning of the misconception that Justin was talking about, because we are starting to see this broaden a little bit, but I totally agree with you where the major definition of that modern data stack is more anchored around that cloud data warehouse. And let's go with that. Let's edit the definition to anchor it there for now, and then we'll be able to go forward and talk more about the open data stack. But so the modern data stack, you know, editing that, anchoring it on the cloud data warehouse. Ryan, why do you think that, you know, specific architecture rose in popularity so quickly? What do you think we were searching for as a data community? What were the answers we were trying to look for? Was it simplicity, modularity? What was it?
I think it was a combination of the two. It was so easy to take a cloud database and like, you know, there's a publicly accessible endpoint that everyone knows how to use. So you can point ingestion tools at it, you can point BI tools at it, and it has great performance. So like that ease was really, really fantastic. And that is, it sets a new bar for where we need to be. Like if I can go and sign up for 3 SaaS products, right? Like let's say, you know, Airbyte and Snowflake and I don't know, some SaaS BI tool. Like that is incredibly powerful because I can get all that up and running and I can have cloud-based data infrastructure in a single day. That's amazing. And I think we want to go there, but there are drawbacks to that approach.
Yes, absolutely. So, Michelle, as we look at this timing, do you think that this specific modern data stack revolution could have really occurred without the rise in popularity of cloud data storage like Redshift, or do you think it was because of that instance or Snowflake or whatever, you know, database you have?
Yeah, cloud is a requirement for the V3 of data, because what has happened, what happened before is that before you had cloud, you had to have a data center, you had to buy your servers, you had to provision for how much data you're going to you have today and how much you think you're going to have in the future, meaning that the upfront cost of operating a data system was really, really high, and that became extremely unapproachable for a lot of companies to actually become data become data driven, like have a data as like one of the first principles of your company and your operations. What cloud did is it gave you elasticity, it gave you unlimited storage, it gave you pay as you go, consumption based pricing, meaning that now I can be a developer that is working on a side project and I want to create and have access to extremely smart, extremely efficient data tools that any bank in the world might be using, or like any big enterprise can be using. I can do it in my bedroom if I want to, and I won't have to spend millions and millions of dollars to get it. So absolutely, like cloud is a prerequisite for this new generation, because you have this elasticity, you have infinite storage, you have access to tools that cost millions before, and now you just pay as you go. So that's one. The other one is also, I think the world has also waken up on how data is being used. So, you know, over the past 10 years, we've created a lot of regulation, first in Europe with GDPR, and after that with TCPA, like South America as one, Southeast Asia as one. Like there is a lot of regulation that are happening. The thing is, businesses, especially tech businesses, are becoming more global on day one. Like even at Airbyte, we have people in the US, but we have people in Asia, we have people in Japan, we have people in Africa that are using, and Europe that are using Airbyte. If we wanted to do it before cloud, that would be hard now that we have all this data regulation. Whereas now that we have cloud, I snap a finger and boom, I have my data stack that is running in Europe and I can be GDPR compliant. So this is also something that happened with cloud. It's just, you can do what every company can do. Like, it has leveled the plane for every company to access data and to leverage it. So absolutely.
Yes, you push a button and you've got everything ready to go. It is pretty fantastic where we're at. So Justin, do you think that the modern data stack is actually modern?
In short, no. I think if modern just means new, sure. It's like a new model year of a car that hasn't changed. I don't think it's actually different in a meaningful way. I think the modern data stack, at least as we've defined it here, which is sort of centered around a cloud data warehouse and has proprietary ETL, proprietary data warehouse, proprietary BI tool perhaps sitting on top. It's really the same data stack that's existed for decades, just built in the cloud. I think Teradata would say, what's the difference? We've been doing this forever. The stack 20 years ago was probably Teradata, Informatica, and business objects or Cognos or MicroStrategy or what have you. What's actually changed? And I think those are that's the reality. Is this is just a replay of the same movie before? To me, I think the opportunity, and we've touched on this, is that there is a actually modern data stack, which is a more open data stack, and that's centered around open formats and open engines and open ETL tools, which is why we have the folks gathered here today that we do, that basically takes out one of the core problems of that monolithic model that precedes it, which is the proprietary lock-in and cost that accompanies it. Nobody, in my time in Teradata, and I spent 3 years there, nobody ever said the database doesn't work. It's actually a great database. In fact, it's better than just about any other database out there. Right? Like, the level of engineering is incredible. That was never the issue. That was never the pushback. The pushback was it became extremely expensive. It was the very definition of monolith. And that lack of flexibility and openness prevented you from, adapting your business to do what you wanted to do. So to me, this is just a replay of a movie we've seen before. And I think the good news is, there's change coming here.
And that's the best part, is now we can sort of shift and talk about the last year. There's been a big movement towards, openness, like we're mentioning, building with an open mindset. And instead of the modern data stack being heard over and over again, we hear more about the open data stack. And so I want to read a definition and again, get a thumbs up. And if you agree generally about this definition about what the open data stack is. So the open data stack focuses on solutions built on open source and open standards covering the data engineering lifecycle. Still has a lot of the same goals as the modern data stack, but the tools integrate better due to the openness, and therefore it is more usable for data practitioners. What do we think? Thumbs up, thumbs down? Middle? Okay. Okay. Michel, let's talk about it. What do you think?
Yeah, actually, there is a thing that is interesting is I almost want to ban stack from my vocabulary at that point.
There you go. Yep, because of all of the hurt and trauma. Yep.
And it's not just that. It's like I've been thinking. Like I think this definition is from Airbyte, if I remember correctly. But it's also that stack. Every time you think about a stack, you think about the LAMP stack, which was like 20 years ago, like Linux, PHP, and other. That, like, a stack has a use case in mind, basically. Whereas when we're thinking about open standard, it's generally not about just use case. It's really about infrastructure, and you build use case on top of it. So that I would say that's the difference. I would say with like when I'm thinking about open source and standard, it's standard belong in the infrastructure domain, not at the stack level. So, but yes, it's to be clear, it's not a fully formulated thought. It's just I thought about
No,
it
I
when
think that's
when you were
great.
reading the definition. Yeah, so that's the only thing I would say. That's the only thing I would say. And for me, the thing that is the most important whenever we talk about like open, it's really what standard are you creating? What interoperability are you creating? And how much control do you keep on your own assets, data assets? Like, do you want your data to be stuck in a system that you have no control over? No, that's your data. You need to be able to, we're talking about warehouses, we're talking about data lake. A warehouse is just one way of interacting with data. If your data is stuck in a warehouse, well, you're missing out on so many other opportunities. So for me, it's really about the standard and the interoperability.
Yeah, let's dig in there, Michelle. I'm going to follow up with you. What about those open standards? What are we bringing to the table? What are some of the open standards we're now seeing that are making the difference?
Yeah, I mean, I think we can just look at Iceberg, for example. Well, Iceberg is compatible with Databricks. Iceberg is compatible with Starburst. Iceberg is compatible with Snowflake. It means that now you can have your storage as a source of truth, and you can plug the best engine for your use case on top of it. And that is the thing that matters. Like these open standards give you this ability. Whereas if you don't, like we talk about like older monolith system, well, you have to be using that system forever. If you don't want to do SQL processing and instead you want to do MapReduce or like Python processing on your data, well, you're stuck. What you have to do is you have to create a secondary system. You have to duplicate all of your data, and that's terrible for data management and for everything we do on our daily lives. So that's really how I'm thinking about it. That it gives you the control over your most fundamental assets.
Yes, absolutely. Justin, what do you think, why the open data architecture has become so important to the data community recently? Is there a reason that it's kind of risen in popularity? Or do you think just the components and principles that it's introduced have really stuck with people? What do you think about that?
Well, I think there are a couple reasons. One is maybe a slightly more technical oriented reason, and one a very practical business reason. I think on the technical front, the open data stack gives the opportunity to end users to customize and change and modify their stack. And we certainly have customers that do exactly that, who build their own connector to a data source, or want to modify something that suits their own very esoteric, specific, customized infrastructure. And with open source, you can do that, especially open source under the Apache license, which both Trino and Iceberg certainly are. Sorry, I'm not as familiar, Michel, with your license. But the point is, you can actually modify that. So that is wildly valuable. The second reason, the more business oriented, and this is like, I think there's that old phrase, like, it's the economy, stupid. I think that like economics drive decisions in a major way. And people are starting to feel the pressure of the quote unquote modern data stack. These cloud data warehouses become extremely expensive, and you are locked in. And what do you do at that point? Again, these were existential problems for the internet companies, which is why companies like Netflix or Facebook, were absolutely, needed to solve this problem. But I think it's now caught up with everybody. I don't think this is purely a Silicon Valley internet company phenomenon, today.
Absolutely. As we mentioned earlier, everyone's a data company now, which is shifting that perspective. Ryan, why do you think that people should incorporate these open standards? And then I have kind of a follow-up to that of, do you think this is another trend, or is this really for real?
Okay, so I think people should use these open standards because, well, like, it's just a massive change in what we can do. I think what's happening with the openness here is like we threw a grenade into the data warehouse space and blew it up. Like it's never going to be the same again. there's this sort of quiet revolution happening where now data warehouses and data lakes and, you know, proprietary or open source or even like Python processes on your laptop can all share the exact same table space. That has never happened before. And it challenges basically all of the technologies that we're working on. And it also like challenges the business model of getting a whole bunch of data and then like, you know, being the only way to access it. Like this is a very profound shift that I'm surprised we don't like just talk about more in the data community. And it has so many crazy implications, like, you know, Justin's points on like dramatically lowering costs, right? Being able to use the correct engine for a given workload and not being forced to use whatever the data happens to be stored in, not needing to duplicate that data and go, you know, manage syncs and copies and pay for additional like duplication. It's a really huge thing, but at the same time, like that, it's crazy because now we have. This is where I disagreed with the definition earlier. Like we have a usability nightmare on our hands. Yeah. Like, okay, so now you can share data across specialized compute engines. That's great. How do you secure that? Oh, you still secure every specialized compute engine individually. And maybe what you do is you add another thing that stores policy, and then you try and sync policy between all of those specialized compute engines, if they support it, because like Spark just doesn't. And so like, but we've really gotten into a weird world where there's a ton of promise. There's a ton of promise to be able to use the right tools and reduce costs. At the same time, like we really need to get to the end of this revolution to see things like, how is all this going to work? How do we plug them together in a truly modular, easy to use way? I think I went a little on tangents there. Sorry.
I love that. No, I kind of want to ask a follow-up with you about usability and modularity. Do you think that those things can coincide, or do you think those are things that almost work against each other?
So I think flexibility and usability are at odds with one another. This is why I use the term modular, because it's not about being able to do anything. It's about being able to build something. It's like Legos, right? If you want a certain, you know, configuration, like you've got bricks. You can stack bricks on top of one another, and they do great. You can do a lot of things, but you can't have one brick stacked on top of another at 45 degrees. There's just like, it doesn't do that. And so we need to learn the constraints of how these things need to fit together, define interfaces through open standards. You know, that's why like Iceberg, we've been exploding in the open standard space. And then like the constraints are actually what makes this easy. So you will be able to do what you need to. You'll be able to use Spark and Trino and Snowflake and Redshift in the same architecture, but you're not going to want to like build everything and like wire it together by hand. We need standards so that those things play nicely with one another.
Absolutely. You need to have the rule book somewhere so that everyone knows how to work going forward. So I think we've talked a lot about kind of the next generation open data stack, open data, whatever we want to replace with stack, replacing that modern data stack, if you will, kind of next leveling that data architecture. And I think something we haven't really mentioned yet is the separation of storage and compute. So Justin, I was wondering if you could talk to us a little bit about kind of separating storage and compute and how that's really unlocked this open data stack and kind of promotes it one of its core benefits. So can you talk about that with us?
Yeah, absolutely. And I mean, I think that the advent of the public clouds drove this as a important opportunity for technologies to take advantage of. And in the case of Starburst and Trino, the technical definition for what we offer is a query engine. And the simplest way to think about a query engine is it's like the top half of a database, right? The bottom half is the storage engine, and you need both, right? Yeah, that's Ryan's waving his hand. That's the bottom half, right? You need both. But the beauty of it is when you have storage and compute separated, you can swap these pieces. They become interchangeable, right? If you wanted to use Hootie, you could use Hootie instead of Iceberg. Ryan will tell you why you shouldn't, but you could. The point is you could, right? And likewise, if you wanted to use Spark, we'd tell you why you shouldn't, but you could. And so customers have, infinite freedom, or what I like to call optionality, to really, define their architecture and build an architecture that stands the test of time. And to me, that's another big piece that has plagued this industry for forever. It's the reason, frankly, Oracle is still a big business, is that customers are very much trapped in that platform. We do a lot of business with very large enterprises in particular. I happen to be in New York today. Financial services is a very important vertical for us. These folks are just plagued with legacy technology that they can't get out of, and have to do these massive multi-billion-dollar transformation projects because their architectures just don't stand the test of time. That's what's so exciting about this, is this actually changes the game and creates optionality for customers, something that will allow them to be more agile for decades to come. And that's really important, especially when you add in, AI as a totally new vector for innovation. And how do I adapt my architecture to handle that? Well, oh crap, all my importance data is still in, my Teradata data warehouse on-prem, or my, what have you. So I think that's really game changing.
Absolutely. And you mentioned interoperability, and I kind of want to pull on that thread with Michel. Can you talk a little bit about the foundation of interoperability being important? How these open standards kind of foster a multi-engine and multi-format, change for our ideal architecture. So where is our architecture going? What are these multi-formats and multi-engines going to look like?
Yeah, I think that to what Justin said about Oracle still being a big business because, well, your data is stuck in a proprietary place and you have no access to it. I think it goes to what we were saying before, which is open formats, open standard. They are actually extremely forward-looking. Like nobody is going to complain in the future that, hey, my data is in Iceberg format. Nobody's going to complain about that, because what Iceberg does is it gives you this ability to have any kind of processing engine on top of it. And when we're looking at if you're looking at your legacy architecture, I think what people are looking at is it's not about rip and replace. I think it's always a terrible practice to just rip and replace what you have. You need to have a North Star, and you need to incrementally kill or move away from a system, but it's never a rip and replace. But what's happening is more giving tools for people to just move to this open standard. Like, how do you move the data that is stuck in that legacy system and make it available so that your future development happen on that new system with the most flexible and modular tools, rather than being stuck in the past. And there is a point, it might take 2 years, it might take 5 years to get through that, because not large company have massive risk to move away from Oracle or from any other system, but at least you're going in that direction. And by integrating open standard, that's what makes you able to move away from existing system, and also prepare you for the next 20 years that are to come, or 30 years. It's just Oracle was built in the 80s, I believe, or the 90s, the 80s actually. So it's a 20 years period where people had things stuck. Now you need to unroll all of that thing and move to the next, what you're going to be using for the next 30 years. And modularity is a big deal. Open standard is a big deal. It did not exist before. We did not have open standard. So,
right, and we're at that shifting place for it. Exactly.
I would also add there that I think the biggest change in what's driving this fundamental shift is centralization of storage. Now that we can share storage, we're going to see a single place for all of this. And that's going to be essentially the last big movement, right? Move your data one more time to something that's stored, using open standards to access and govern and, work with that data. And then it is universal data, right? A universal lower half of your database is an incredible step forward. That means, yes, you can plug in different modular query engines on top when, you have a different use case that it's fundamentally not designed for. I think it's going to allow compute to become more and more specialized, get better and better at streaming versus ad hoc versus, ETL or, whatever. But it's all part of the same sort of unified architecture based on cloud storage that can scale to however large you need it to be, and then a table abstraction and services to be able to run warehouses at that scale.
Call me a skeptic, Ryan, but I just, don't know how I feel about centralization, because I feel like I've heard a lot of stories of it going wrong. Can you talk a little bit more, kind of just pull on that thread a little bit of what you mean, one more move, and why centralization is important to you?
So the centralization is made possible now because we're pulling apart these two pieces of a monolithic data warehouse. So centralization, it was like the story of data warehousing, right? Like, hey, collect all your data in one place, you'll be able to use it all together. And just that capability was fantastic. But then we had, we acquired another business unit and they've got their Vertica system and we've got Teradata, and like, okay, now we have two. Or, marketing has all their marketing data in their own. Large organizations, you could not actually centralize. And we're also, because these things were tied together, glued together, you can't make decisions about them independently. So I can't say, hey, my reporting use case can run over here, and my other analysis use cases like financial analysis can run over here. That doesn't happen. Like, you've got to choose one because you're centralizing data. Well, we've now, by blowing up the data warehouse, we've alleviated the need to choose one. You can use whatever you want, and as long as it's all modular and fits together, plugs in correctly, you can use any tool. And that, I think, is why I would describe this as one of the last moves to centralization. We can handle the scale of a truly centralized store. We can not be tying you or locking you into a particular compute option or paradigm or solution or anything. So like, centralization just makes a whole lot more sense now. And it also does for like governance and access controls and things like that, where you don't want to lock everything down externally. So that's my pitch for centralization.
You're a visionary, Ryan. We'll see. I'm a little bit more towards you now, but I still struggle with the concept, but I'm excited to see how it goes. So I think we've all talked, and kind of agreed upon that openness is something that's here to stay. It's that next generation. It's something that we can, it's really changed how we've looked at data previously. And with that in mind, I think we've all touched on this, but I want to kind of nail down deeper. People are reconciling their existing architectures at organizations, and then they're having these innovative data approaches of wanting to introduce openness. And there can be some friction along that journey. So, Michel, how do you bridge that balance between sort of keeping the lights on with the existing legacy architectures and then still trying to revolutionize and incorporate those open standards?
Yeah, I think it goes back to what Ryan was saying, which is, and what I was mentioning before, which is it's just a matter, like, you need to keep the lights on. There is no other choice. Like, this legacy system are most likely business critical to you. You've built a lot of your company on it. It's more a matter of, where do I go from now and how do I evolve? And yes, centralization, sorry, Monica, it's actually a good thing on that front. Is the fact that you can centralize where your data is stored without having to care about how it's going to be used, this is how you revolutionize your data infrastructure, because you are separating your business use case from core infrastructure. And that is the thing. And from now on, you just need to have your North Star and just evolve. Like, okay, I'm going to take this particular use case where I depended on that legacy system, but now the data is available. It's on S3, it's on GCS, it's on Azure Blob Storage, it's on my whatever, like infinite buffer of data I can have. And I'm just going to take this one and I'm going to replace this legacy use case by the new one using whichever system I want on top of it, one that is actually tailored for that use case. If it's a marketing team, that might be a warehouse. If it's I don't know, like a data science team, it's going to be a different tool. And that's, I think, what's happened. But you need to keep the lights on. You cannot just rip and replace. But you need to move in the right direction. You need to have like this data stored and available so that bit by bit, all your projects rip out legacy system and bring you into the future. So yeah, that's the only thing I have in mind for this one. Yeah.
Well, and you'll be better for it too, because like you mentioned, then the usability goes up and then people are able to access the data themselves as opposed to asking other people for that, which I know all of you have touched on as being critical going forward. So yeah, absolutely. I think that completely makes sense.
Yeah,
Justin,
and actually, like this, just one thing, like the thing about the centralization is that now you can have any people at the company, yes, actually deciding what is the best system that they can use to actually do something with that data. So there is almost like a self-serve aspect to how you work with data. Security, yes, becomes even more important at that point because now everybody can do anything with data and you don't want that. But yeah, it's that's the future, is the flexibility, the modularity, and like the self-service on top of data.
Absolutely. Justin, what do you think are some of those first steps an organization that has a complex data ecosystem could take to start thinking about openness and optionality?
Yeah, well, and maybe I'll respond to a couple of the comments from your previous question as well, or previous questions, because this may actually be the first point in the webinar where I have to disagree a bit with my colleagues, because the idea of centralizing all of your data, even within, well, certainly within a large complex enterprise, seems very challenging for the simple reason that I think you're always going to have still purpose-built database systems. Like the entire world can't run on Iceberg for all types of applications, OLTP applications, very specific database systems for time series and, for trading data and so forth and so on. It's sort of like Mike Stonebreaker, famously said, and of course he's the Turing Award winner and creator of Postgres and Ingress and so many different database systems, that there's no one size fits all database system. And so for that reason, along with the reasons of M&A and, so forth, I think you're going to always have data that lives outside of your central lake. I do think that absolutely you should store as much data as you can in your, in your lake house, if you will, with open format. So we agree on that. I just don't know that we will get there entirely. And so for us, at least, that is also very core to why we designed the system the way that we did, which allows for federation, allows for the ability to access other systems where that data may live, and be able to join that data together. So you have really the optionality to query it in the lake, which is going to be your best TCO for sure, but also being able to access data outside of the lake. And so to answer your question directly, Monica, I think that the first steps for an organization, one of the things that we recommend, get your lake in order, modernize your lake. That might be, upgrading from a Hadoop environment that you've had for a long time, going to object storage, using Iceberg, we would absolutely recommend. But there are other open formats as well. And then lastly, use a query engine like Starburst or Trino, and start to actually use that as your lakehouse, while being able to actually still federate and access data that lives elsewhere as well. It's probably the fastest way to get access to sort of all of your data within an organization.
Absolutely. Ryan, I saw you nodding and kind of putting your thumbs up. Do you want to touch on that at all about
Yeah, I think centralization, like I'm big on centralization, but I think it's probably that Justin and I agree on this. I'm not talking about transactional data. We don't keep our transactional databases running the 24/7 production product that are distributed across several different regions. We don't keep that stuff in Iceberg. Of course, there are going to be things like that. I'm talking mostly about the analytics space and the ability to centralize as much as possible. Centralization is a good trend to the extent that you can do it and still meet those use cases. So I would not quibble with the point that like not all your data is going to the lake. Of course, yeah.
Your lake can be your center of gravity, and then that's where you put the majority of it, and then you build from there. So
it's like it is your repository, but yes, it's and that's why at that point, like being able to move that data around becomes very critical. Is that you don't know, you have your repository, but maybe that data would be better if it's stored on Salesforce for whatever reason you want. That's also a thing. It's like operational system cannot be replaced by storage. That's also the thing.
Absolutely.
Okay, so we agree.
We absolutely.
Good.
We still haven't convinced Monica.
Oh, good. Well, I'm in. So that makes me feel much better that we can end the webinar all together on the same page. So. I think to close out, we got time for one more question. Ryan, what advice would you kind of give on building a sustainable data strategy that kind of outlasts these architectural trends that we're talking about?
So I think the new capability that is groundbreaking is the ability to share storage. That's new. That's never happened before. We're pulling apart the data warehouse. And so I would just encourage people to start thinking about the new questions in that space, right? If we pull apart the data warehouse and we have storage and compute as separate things, what gets centralized? What specializes? What do you want to use there? And also start evaluating architecture in different ways. I mean, most people today still evaluate architecture by going, if I take a random set of queries, how fast are those queries on this system versus that system? And like, there's so many more questions to answer here. Is my storage in that system going to be reused for the next hot query engine that comes out? Is it compatible with Starburst? Right? Like that's a really good question to ask. And I think people just need to start thinking about it in those ways.
Let me know. Email me at Monica Miller and I'll make at starburstdata.com and I'll make sure it's compatible. We'll work on that. So I just want to thank all three of you so much. I had a wonderful time. There's a lot of great insight, and I just want to thank you for the conversation and really everyone who joined. Thank you for joining us. I think it was a really fun afternoon.
Thank you all.
Thank you.